Okay, here's problem set 4. So the half-life of phosphorus 32 is 14.3 days. We're going to find the number of phosphorus atoms present in a 1 millicurie source. And what is the activity of 1 millicuries of phosphorus 32? All right, so let's start out here. So the number of atoms per gram, we're going to take Avogadro's number divided by the atomic weight. So we know here that we've got 6.02 times 10 to the 23rd atoms per gram. And we know we have 32 grams. So we end up with 1.88 atoms times 1 gram. And that's going to be equal to 1.88 times 10 to the 22nd atoms per gram. So now we take a look at the activity. That's going to be multiplied by lambda times n. Lambda, in this particular case, we know what the half-life is. If we take this and translate that into seconds, that's what this is. So this becomes lambda. And we can see that here if we take 14.3 days, multiply, divide by 1 day, replace it with 24 hours, divide the hours by, and multiply by the number of minutes. Then we have the number of minutes here and multiply by the number of seconds, and that's where that comes from. Okay, so we have the number of atoms. We have lambda. All we have to do is to multiply through all of that together. So we take lambda, multiply it by n in this particular case, and we know that we end up with 1.5 times 10 to the 16th decays per second per gram. So if we have the number of decays per second per gram, and we take that decays per second, which is more of a becquerel unit, but we take that and we figure out how many millicuries we have by dividing by the number of becquerels. Then we end up with 2.8 times 10 to the 8th millicuries per gram. Now, we're not exactly sure how many grams that we have at the beginning, but for however many grams that we do end up with, this is what the activity is going to be. Part 2, we've got a source of 198 gold with the initial activity of 10 times 10 to the 8th becquerels, and that's used on a mold and worn by a patient for 5 days, and find the remaining activity. So we know the half-life of this gold 198 happens to be 2.7 days. We determine lambda from this. We know what lambda is. We know what the initial activity is here. So we put in for lambda, and we know what activity, what time the activity goes for is 5 days. Put all that information in, and we can determine here that we have 2.77 times 10 to the 8th becquerels. So that's what the exposure is for that amount of time. Now, if we're interested in finding what the activity, how much activity is in millicuries, we can obviously work that out, but it's not necessarily asking for that. I think I would word this question a little bit differently. I think I would say find the remaining activity, because the way that presents itself, I think that tends to indicate that, you know, there's some sort of activity remaining after this. I would just say, I wouldn't say find the remaining activity. I would say find the activity after 5 days. I think that would be a better way of saying that. I'll try to remember that as I'm putting that into digital form. So let's take a look here at number 3. The half-life of sodium-24 is 15 hours. Calculate the mean life of this nuclide. When will the remaining activity be 40% of the original activity? All right, mean, of course, is the same as average. In order to find the average life, we take the half-life multiplied by 1.44. That gives us this. To determine lambda, we take 0.693 divided by 15 days, come up with this. So the activity, so we've answered the first part of this. The activity for 40%, basically we take the equation here for activity, divide both sides by A0. In order to get 40% over here, basically it's 40 divided by 100. So we would have 40 divided by 100 is equal to E raised to this power. So we're going to take the natural log of both sides. When we do this, exponent becomes a coefficient, and the natural log of E is 1, which is one of the reasons why we took the natural log. So we got the natural log of 0.4 is equal to this. There should be a negative here in the front. When you do that and you divide both sides here, you can determine what the natural log of 0.4 is. You're going to divide it by 0.462, and you end up with 19.8 hours. Okay, so I hoped that this helped you to some degree.